database anyway, right? Like most of the world's application software is resting on top of a SQL database, and doing it in SQL is just easier than writing application code to do it. So why not use your SQL database to help you out with this re-ranking problem? So here's the general outline of the SQL to do reciprocal rank fusion for 2 rankings. I'm not going to generalize it to n rankings, but you can generalize this to more than 2 rankings. So there's this query has 4 common table expressions. So let's look at the first one. So this first one right here is to find the top full text matches. So this is a select query that finds full text, the top n full text search matches and produces a score for them. I'm not giving all the SQL, I'm just giving like an outline of it so it all fits on one screen here. And then the second one is to find top vector matches. So we find the top n vector search matches, and this has another score. So we've got scores 1 and scores 2. Then R1 and R2 are the rank ordered lists for scores 1, the full text matches, and scores 2, the vector search matches. And it's super easy to use SQL to do a row number with an order by of the score and produce the rank. You order in descending order. So the highest rank value will be number 1, the one with the highest score. The second rank value will be number 2, and so on. So now I've, in this easy breakdown, 4 basic steps, I've got the 2 ranked ordered lists. I produce rank numbers for each of them and add that on to the original results. And now I combine them. So in this case, I'm doing just an equal, I'm doing a weighted sum of the 2. So you've got, suppose I want to give like slightly more weight to the first one than the second one. I could say like give 0.7 weight to the first one. I could use 0.7 for my weight. And then I got 1 divided by the rank plus 60. This is the smoothing factor, 60 right here. And I'm using this NVL function because I'm doing an outer join. So in one ranked list, some of the items might not appear, and we want contribution from either list, even if it doesn't appear on one of the lists. So that's why we're doing this outer join. So if I have a null rank because the outer join doesn't produce anything on one and in one of these 2 lists, then I just put in some large number as the rank, like 1,000 or 10,000 or something. That way it will get very little weight contribution, but I want, I still want to produce a little bit of weight contribution so all the math works out right and all the rows get accounted for. So this is the general structure of how to do reciprocal rank fusion in SQL. So now let's demo it. So here you'll see I'm logged into the single store Helios cloud service to get access to single store database. And I've already loaded some data. I have this table called Vex that's got an ID number, a URL column, a paragraph, a vector embedding for that paragraph, and that's the information that I'm querying. So this is all covered in the single store documentation. We have a documentation page about how to do hybrid search, and it talks about this reciprocal rank fusion that I'm covering today, and it has the setup for the demo that I'm going to show you. So you can go to our docs, and we have created a small data set with maybe 40,000 rows or so of information describing Wikipedia articles about video games. And so we've already got vector embeddings stored in that vector data set, and you can load that from our, using the instructions in our documentation. And so suppose you want to ask questions about video games, you can do either full text search or semantic search of this VEX table to answer questions about video games. So I already have loaded all the data, so I'm going to skip the first part there. And I've created vector indexes and full text search indexes to help run my query a little bit faster. But that's not really necessary when you're talking about reciprocal rank fusion. It doesn't matter how you get the ranked results. It just matters that you have them. And so here I've got this is a full text search query to search for paragraphs that contain the word Super Mario Kart. So I'm gonna run that, and I also have this. I'm gonna use a vector to find stuff that's similar to Super Mario Kart. I'm just gonna take the vector from the database about Super Mario Kart to be my query vector. Okay, so now I got my vectors, and now I'm going to run this query, and we'll see that it produces ranked output where it combines the ranking for full text search and the vector search in a principled way using reciprocal rank fusion. So first, let's look at the output at the bottom here. So there's 5 items that I've retrieved because I put a limit 5 down here. And so they're all about Super Mario Kart. And so notice the full text search scores are in the range like 0 to 10. So I've got ranks like numbers like 8, and 8.5, 8.8, 8.3, 8.2, 7.3. The vector search scores are all in the range -1 to 1, the 1 being the highest, the closest match. So the here's the full text search ranking 2, 1, 3, 5, 9, and vector search ranking 1, 7, 1, 11, 8, 6. Now this is the combined scores between the two. And so the item that got ranked at the top had a full text search ranking of 2 and a vector search ranking of 3. So it wasn't ranked the highest on both lists. And that produced a combined score, which turned out to be ranked the highest overall. Then full text search rank number 1 and vector search rank 7 happened to be the second highest rank, and so on. So if we go back and look at this query, it's got the 4 blocks that I outlined on the slide earlier. It says first find the top full text search matches. So I'm going to find the top 200 full text search matches, find the top 200 vector search matches. This is vector-based semantic search. And we got vector embeddings for the paragraphs from one of the OpenAI models. But you could use any AI model that is suitable for you to get vector embeddings to do semantic search. And then we produce the ranking for full text search and the ranking for vector search. And down here, we're combining the ranks with reciprocal rank fusion. In this case, I'm using weighting to produce 0.7 weighting for full text search and 0.3 for vector search. So I'm weighting the full text search a little bit higher. I could have weighted them 50-50 just to show you that you can do weighting to slightly tweak how you do the reciprocal rank fusion. I'm illustrating that here with this weighting. And so again, the cool thing about this is this works for any SQL database where it allows you to produce multiple different types of ranking. In this case, I'm talking about vector search and full text search and doing hybrid search using RRF. That's probably the most common application, but you might have some heuristic ranking from just like a business intelligence style query or analytical query in your application, and that can produce one ranking, and then another ranking could be like a vector similarity search or something. It doesn't have to be full text and vector similarity. You can, anywhere you produce a ranking and you want to combine rankings, this is a nice way to do it. So with that, I'm ready to take questions now. I appreciate you coming to this webinar, and fire away if you have any questions.
Hi guys, so we are officially open for the Q&A session. Eric, I don't see any questions right now, but
Okay.
anyone that has joined live, if there's any questions, please feel free to drop them in right now. If not, so there's one question from Boris. They say that, is there any common third type of a rank?
Is there any common third type of a rank? I think that question probably is because I said that you could have any number of ranks like R1 to RN and combine them all. And I would just say, you might have many different possible rankings. I think the common third type of rank might be some sort of ad hoc ranking from a query that, where you're sorting maybe some numeric value in your query. But for hybrid search, the common types of ranks are these two, the vector-based semantic similarity and the full text similarity.
So there's another question. They say that the single store offer a sandbox environment for us to practice.
Absolutely. So the easiest one to use is to go on single store Helios and sign up for a free um, trial on Helios, and you can get up to 1 GB of data and 10 tables or something. Then you can use it indefinitely. There's no cost to you. There's no time limit. So that's the easiest sort of trial environment. If you need a bigger capacity to try a lot of data, you can get a free trial with, I believe it's up to $600 worth of free credits, also in Helios. And we also have a developer container that's like a Docker container that you can use for self-hosted installation. And so if you just Google for single store free trial, you'll get information about both of those.
All right, sounds good. So there's another question from Saksham Jain. They say that when applying RRF's hybrid search in SQL, how does the choice of K interact with different retrieval models like BM25 for keyword search and vector embeddings for semantic search? Could tuning K differently shift the balance between lexical relevance and semantic similarity?
So the choice of K, so BM25 is just one sort of full text search scoring model. And so the key thing about reciprocal rank fusion that you got to remember is that it doesn't care how the original rankings were produced. It just cares about the rank number. And using different K using different values of K could produce different outputs, yes. But using that K60 is just a way to smooth things out so it doesn't overweight the top few items like 1, 2, 3. So yeah, the exact type of scoring model used in your vector similarity test or your full text search, whether you're using BM25 or some older scoring method for full text search, doesn't really matter. It's just the ranks that matter. And people have experimented with different values of K, and 60 seems to be good. So probably just stick with 60, or definitely don't make it too small a number. Like making it 0 is not good because you get those sort of too much impact from being ranked 1 or 2.
All right, sounds good. So seems like we don't have any other questions. Folks, if there's any other question that you have not been able to ask right now, you can always reach out to us on LinkedIn. You can message me or Eric. We also have team@singlestore.com. You can email us there and we will be able to address any. Also, one more question popped up from Boris again. Uh, does that technique improve the perceived accuracy of the results? Can you answer that, please?
Yeah, I mean, using a smoothing factor does improve the perceived accuracy of the results because it doesn't overweight the top items. Yes.
All right. So, guys, if there's any questions, this is the time to use the Q&A button and add it here. If not, you can always, as I mentioned, you can always reach out to us on LinkedIn. Our DMs are always open. You can also email us at team@singlestore.com. A very, highly qualified team will be, signed to you and would be able to assist you very well. So, yeah, I see, like, if there's no other questions, we can end the session early. Eric, do you have anything else to say?
Uh, in a news website, there's one more question. Should I take that?
Oh, okay. Oh, absolutely. Absolutely.
It says in a news website like, Wall Street Journal, New York Times, can reciprocal rank fusion be helpful? Sure, like anywhere you're doing search, if you're trying to combine full text search and vector-based semantic search, yeah, you can use this. Doesn't matter what kind of documents. A news site could be could be a good application for it if you're doing combined semantic and text search.
Always reach out to us if you have any use case like that. We would be happy to chat about it. Like if even if it's a project that you're working on, you want to utilize single store, we have a very interesting free share tier, and a lot of people have been able to build a lot of interesting stuff using that free share tier. So uh, go check that out. As Eric mentioned, we have $600 worth of free credits, and they last really long. So for me, it's going to be over 2 years that I've been working here, and I still have those credits. So I'm just saying that they really last you for very long. And yeah, seems like we finally don't have more questions. Guys, please keep an eye out for for an email from me, and it will have the recording of the session. It will have any resources, which is a blog post and a documentation that I will be sharing with you. For any more details, please reply to the same email, and I'll be there to assist you. And thanks, Eric, for your time and doing this amazing session with us. I hope more and more people make good use out of it. And thanks, everyone.